All right, here's your sample problems, you guys. Number one, I don't know if I should have wasted your time with that, but look, the vertex, that's what this is asking for. Where's the vertex? So um, we look at it, we go one to the right, three up, okay? Um, Now, with that being said, we look at this. This is in readable form. That's what we need to do to this, this, and this. I can't tell what the vertex is by glancing at it. Can't tell. Can't tell. That's why the pre-lesson, I showed you how to complete the square. Remember rule number one. This has to be a 1. Notice this one isn't. That one isn't. I didn't have any of these examples on the pre-lesson, but here you go. This one is what we did in the pre-lesson. So you just take the constant. First of all, that's a 1. That's your first check mark. Bump that over and then create a couple of spaces. So take half of this number, which would be -4, square it. That'd be 16. Now if that's 16 and it wasn't there initially, I got to balance it by putting a -16 over here. Now this is my perfect square trinomial. So I'm going to change that to a y just because. 2 factors of 16 that add up to -8. That'd be x minus 4 and x minus 4. I don't want to write it that way. I want to write it x minus 4 squared. It's the same thing. After a while, you won't even take this step. But if you need to take the step, no big deal. And then what's 5 plus -16? That'd be -11. And that equals my y, or my g of x. What's my vertex? 4 to the right, down 11. There it is. Now they might ask you, where's the axis of symmetry? 1, 2, 3, 4. Divided by 11, so it's down here. This is a 1, so it's going to be like this. And then your axis of symmetry would be that vertical line, x equals 4. All right, just throwing that in for free. Okay, move on to this one. This is where it's going to get a little trickier. Remember rule number 1? That coefficient needs to be a 1. So a lot of you are like, I know, I'm going to multiply this all by -1. Well, the problem with that is we get -y equals x squared plus 4x minus 1. Okay, we took care of this, but we just screwed that up. Remember, we don't want a -y. So good try, but that's not what we want to do. What we're going to do is something you haven't done in a while. We're going to take a look at these first two terms. We're going to factor out a -1. So we're going to go -1. Now watch this. I'm going to get x squared plus 4x plus space. Remember what we do with this? We kick it to the curve. Plus 1 plus space. Now this gets a little tricky. We put that parentheses in there to enclose my to-be perfect square trinomial. Don't worry about this. Don't worry about this. Focus on your perfect square trinomial. Take half of that. What's that? 2. What do I do next? Square it. What's 2 squared? 4. Now, I know a lot of you are like, aha, I'm just going to put a -4 there. And we just screwed it up. Why? When we put that 4 in there, it wasn't there originally. Notice there's a -1 out in front, so technically I put a 4 there, but the -1 hits it, making it a -4, is what I put on that spot. So I got to make up for it by putting a +4 there. If you don't pick up on that trick, things aren't going to go well. So this is a perfect square trinomial. So now I got y equals -1. What does that factor into? Well, I know it's going to be something squared. What are 2 factors of 4 that add up to 4? 2 and 2. So I'm going to put +2. And what's 1 plus 4? That's 5. Where's the vertex? Well, that'd be left 2. Sorry about that. Left 2, up 5. There's my vertex. And if they ask us other questions, does it open up upwards, downwards? Well, that'd be opening up downwards because it would reflect over the x, but that's not really our goal today. All right, last sample problem. As you can see, this is a 2. Now, some of you brainiacs are like, hey, I'm going to divide by 2, divide by 2, divide by 2. The problem with that is we'll have to divide that by 2, and we don't want y over 2. So that's a good idea, but no. So on these weird ones, concentrate on the first two. Remember, we're just going to kick that to the curb in a minute. Don't mess with that one. What can we do with this? Well, we're going to make it y equals, what can we factor out? Just like we factored out a -1 from there, we're going to factor out a 2 from there. So we get x squared plus 4x. Now is the time to create your trinomial. I'm going to put plus -6. I could have just put minus, so why don't I just put minus, plus space. Now here we go. Notice I have a 1 there. That means I can have a perfect square trinomial, just like I had a 1 here. Got to have that. So what's half of 4? 2. What do I do with that? Square it. Where do I put 2 squared, which is 4? I put it right there. Now notice that 4 wasn't there. So now I didn't just add a 4. I added 2 times 4, which is 8 in this space. So I got to make up for it by putting a -8 over there. Now I make it look readable. 2, what does this factor into? X plus 2 squared. -6 minus 8 is -14. Where's the vertex? Well, that would move it left 2, down 14. There's where my vertex would be. Hopefully you're getting this, the gist, okay? So good luck on that homework. Let me know if you have any questions. So I almost forgot. There's one sample problem that I want to show you where you can use decimals. We'll talk about that in 2 seconds. Okay, so as you can see, I've got this crazy looking quadratic there in my decimals. -10x squared plus 700x minus 6,000. So remember, there will be tests where you'll be allowed to use, graphing calculators, decimals, and then there'll be things like SAT, ACT, where, there's non-calculator portions. So some of you are going to say, well, why can't I just use decimals for all of these after you see this example? And the reason is you need to have that skill completing the square. In the event, like on your test, you're not going to be allowed to use graphing calculators and decimals on all of them. You're going to have to show your work. But some of these are so ridiculous that it's like, come on. So you just got to use decimals. And this is one of them. So this is a problem, example 3 from page 82 in your textbook. It talks about this crazy function showing a profit from a company earning money after selling headphones at different prices. It says, what is the maximum profit the company can expect to earn? So I typed it all in there, and it looks like we just have like a vertical line. But if I move out big time, you can see, parabola. It's a weird one, and then it starts to get skinnier and skinnier the more I zoom out. But it is a parabola, and I still haven't found the maximum, and there it is. If I drag my cursor right over the top, the answer to that problem would be 6,250. Not my x value. They want to know what's the maximum. So remember, if a parabola goes up and comes down, it's got a maximum. If it goes down and comes up, it's got a minimum. This one has a maximum, 6,250. And there you go. All right, guys.